Yes, is it visible now?
Yes, sir.
Yes, sir.
All right. Ask your doubts, Harry. Question number, in exercise 10.3. Any doubts? Question number 1 to question number 18. Nobody is having any doubt. Yes. Question number
11,
11. Yes. Any other doubt?
16.
16. Okay.
So 14th.
14. All right. Let's first see question number 11. We have to prove that the line through the point x1, y1 and parallel to given line is. So basically, we have to find equation of line. We have to find equation of line passing through x1, y1 and parallel to this line. Ax plus by plus c equal to 0. So first of all, given line is ax plus by plus c equal to 0. Let us find its slope, and we can find its slope by changing it in slope intercept form. So I told you that if you have to change a general form in a slope intercept form, then you will keep y to the left side and all the other terms on the right hand side. So because of that, I have transposed these two terms by and c to the right hand side, and ax and c to the right hand side, and then I am dividing the whole equation by b, that is coefficient of y. So now it is of the form y equals mx plus c. So from here we can see that the slope of given line is minus a by b. Now the line that we have to find is parallel to this line. Now required line is parallel to given line. That means their slopes will be same. M1 equals M2. Therefore slope of required line is minus a by b only, because if two lines are parallel, their slopes are equal. And this required line is also passing through the point x1, y1. Hence we can write its equation. Equation of required line will be, because we have its slope, we have a point through which line is passing. So equation will be y minus y1, then slope m into x minus x1. So here we are using point slope form. Then transpose b to the left hand side, and in the next step you can transpose the term on the right hand side to the left hand side. It is negative here, so it will come here on the LHS with the positive sign. So this is the answer, and that is what you are supposed to prove in this question, that the equation of the line passing through x and y1 and parallel to given line is this. This is our answer. This was what we were supposed to prove. Now question number 14. Find the coordinates of foot of perpendicular from the point to the line. Okay. Let us make a rough diagram. Suppose this is the line. 3x minus 4y minus 16 equals 0. And we have a point P minus 1 comma 3. Obviously not on the line. If you want to check whether point P is on the given line or not, you will put the values of its coordinates in place of x and y, and you'll see that LHS is not equal to 0. Point is not on the line. That is why we can draw up a perpendicular from this point on this line. Say this point is M. We have to find the coordinates of M. Okay. This is an important question. It may come in your school exam. So we have to find the coordinates of point M. let us say the coordinates are h comma k or x1 comma y1, whatever. So basically, if we have to find the coordinates of this point, we need two equations. Based on this diagram, based on the given information, can anyone tell me what are those two equations or what are those two conditions which you will use from here? How you will establish a mathematical relation between h and k? Anyone can answer. What is the information that you can draw from this diagram?
So product of slopes -1.
Product of slopes is -1. Very good. See, slope of, I'm writing PM in suffix. That means M stands for slope here. So M PM means slope of PM into slope of line. This will be -1. Why? Because both of them are perpendicular to each other, and product of slopes of two perpendicular lines is equal to -1. Now we need to find the slope of PM, which I can find using 2 points, because the 2 points are -1, 3 and h, k. So the formula is y2 minus y1 upon x2 minus x1. x1 y1 and x2 y2. x1 y1 and x2 y2, they stand for the coordinates of the point P and M. Okay. Then slope of line. See, for this also we need to change it in slope intercept form. So I will write 4y equals 3x minus 16. Divide both sides by 4. So slope of the line is 3 by 4. You put this value here, 3 by 4. Comes out to be -1. Solve this. 3k minus 9. Denominator it is h plus 1 into 4. That is 4h plus 4 equals -1. Simplify this equation. So 4h plus 3k comes out to be equal to 5. This is one equation. You need another equation in h and k, so you can solve both these equations and you can find h and k. That is the coordinates of M. So what is that second condition that you will use in this question? Yes. What is that other information? Because what is M? M is the foot of perpendicular. Okay. PM is the perpendicular. Perpendicular has been dropped from P. So M is called the foot of perpendicular. We have to find its coordinates. We need another equation.
So substitute h and k in x minus 4y minus 6.
Yes. Good. Good. Also, point M lies on the line. Point M lies on the line. So whenever a point is there on a line, what is the meaning of this? Mathematically, it means that point will satisfy the equation of line. That means in place of x you put h, in place of y you put k. So that's why 3h minus 4k equals 16. This is second equation. Solve both of them and you will get h and k. Okay, linear equation and two variable, anyone can solve. That is what you are supposed to do in this question. 14th. Remember, one concept is lines are perpendicular. Next is point lies on the line. With the help of these two, you will be able to form two equations, and solving them you will get the coordinates of foot of perpendicular. This is the concept. Now question number 16. P and Q are the lengths of perpendiculars from origin to the lines this and this. Okay. So there is this point origin. Okay, origin means 0, 0. We are dropping a perpendicular from it to two different lines. One line is x cos theta minus y sin theta equals k cos 2 theta. We will shift k cos 2 theta to the left hand side. And the length of this perpendicular is given as p. And we also have the formula for the length of perpendicular. Formula is you put the coordinates of the point in place of x and y in this expression, right? If you remember. So what will remain? When you put 0 in place of x, it will become 0. Next one will also become 0. Only minus cos 2 theta will be remaining. And in the denominator, we write square root of sum of square of the coefficients of x and y. That means cos square plus minus of sin theta whole square. So this is mod of minus k cos 2 theta by 1. Why? Because in the numerator it will become cos square theta plus sin square theta, which is 1. Square root of 1 is also 1, right? And we have to prove that p square plus 4q square is k square. So this is p. So if we square both sides, that means we have to square this result also. So now modulus is of no use because we are squaring. Negative will also be removed and p square will come out to be k square cos square 2 theta. This is first. Now from the same point 0 0, we are dropping another perpendicular on a different line, which is x into sec theta plus y into cosec theta minus k. This time the length of perpendicular is q. In the first case it was p. Okay, but same formula will be used. Q equals, again you put 0 0 in place of x and y, so what will remain? Only minus k by under root of sec square theta plus cosec square theta. Now if you look in the question, it is p square plus 4q square. So you square this first. This is k square upon sec square plus cosec square. You simplify this term, change it in sin and cos. 1 by cos square plus 1 by sin square. This is also important question. Then you take the LCM. So this is sin square plus cos square. In the denominator it will be cos square into sin square. So k square comes out to be k square cos square sin square. Why? Because sin square plus cos square will become 1. Now you multiply both sides by 4. Why? Because in the question it is 4q square. And also on the right hand side you will observe a formula. So this becomes 4q square and this whole thing 4 cos square sin square. It is basically whole square of 2 cos sin or 2 sin cos. 2 sin cos is sin 2 theta. Formula of sin 2a. So this becomes k square sin square 2 theta. Next step you will get the answer. You have the first equation as p square equals k square cos square 2 theta and 4q square as k square sin square 2 theta. Add these two, you will get k square. Adding one in first and second equation, 1 plus 2 gives p square plus q square 4q square. The right hand side it will be k square cos square 2 theta plus k square sin square 2 theta. Take k square common, rest it will be 1 cos square 2 theta plus sin square 2 theta identity. So that is what we have to prove, that p square plus 4q square equals k square. This is the result. This was the 16th question. Any other doubt from the exercise? (10.3) any doubt? Okay, what about the miscellaneous exercise? Miscellaneous exercise on chapter 10. You might have solved it by now. You can ask your doubts from that exercise. Yes, miscellaneous exercise doubts.
So question 5th.
Question number 5. Yes, still question number
So
10.
scroll up a bit.
Sorry.
So question 10.
Question number 10.
Yes, sir. Wait.
Till question number 15. Till question number 15. Okay, I'm discussing the questions till question number 15 only. Rest 9 questions we will discuss in tomorrow's class. So first 15 questions. Any other doubt?
So 11.
11. All right, let's see these questions.
So could you show the 14th question, the last step? I'll just take a screenshot of it.
Yes.
Okay, sir, done.
All right. Okay, question number 5. Find the perpendicular distance from origin to the line joining the points this and this. Okay. So basically first you have to find the equation of line and then you have to find the perpendicular distance. Question is something like this. There is this line which is passing through these 2 points, cos theta sin theta. Another point, cos phi comma sin phi. Different angle. Okay. And there is this point 0 0 and you have to find the length of perpendicular draw from it. But first you need to write the equation of line, and that you can do by using the equation of line in 2-point form. Okay, so like this point is x1 y1, this is x2 y2. So you write the equation of line first, then you use the length of perpendicular, formula of length of perpendicular. So equation of line is y minus y1, then y2 minus y1 upon x2 minus x1 into x minus x1. Actually, we need to simplify this equation first, and for that you need to use trigonometric formula. So in the numerator, it is sin c minus sin d. Sin c minus sin d, formula is 2 sin c minus d by 2 cos c plus d by 2. Denominator, minus 2 sin c plus d by 2 sin c minus d by 2 into x minus cos theta. So 2 will get cancelled, sin theta minus pi by 2 gets cancelled. Now what you can do, you can shift this term in the denominator to the left hand side. So it will be minus of sin pi plus theta by 2 into y plus sin theta sin phi plus theta by 2. Then the right hand side you have this term, right? So this is x cos phi plus theta by 2 minus of cos theta into cos phi plus theta by 2. Now you write all the terms on one side. So what we can do, with x we have cos phi plus theta by 2. With y we have, now we are shifting this term to the right hand side. Okay, so sin phi plus theta by 2 y, and this term also minus cos theta cos phi by 2. So mainly the question is based on writing the equation of line and simplifying it. The length of perpendicular you will get in a single line, minus sin theta plus phi by 2 equals 0. Now whether I write equal to 0 on LHS or RHS, it is same. So Finally, we will have to use one more formula of trigonometry. Then you will get the answer in the simplest form. And to use that formula, you will take minus common from both the terms in the last. When you take minus common and you read theta as A and this whole angle theta plus pi by 2 as B. So formula will be, it is of the form cos A cos B plus sin A sin B, right? So cos A cos B plus sin A sin B is cos A minus B. What is A here? A is the first angle theta. I am simplifying these terms on the this side. Okay. First angle is theta, next angle is pi plus theta by 2. So when you simplify this, after taking LCM and everything, you will get theta minus pi by 2. So I write it here, cos theta minus pi by 2 equals 0. Okay. So what I have done? First I have taken negative common from last two terms. Then it is of the form in the bracket, it will become cos A cos B plus sin A sin B, which is cos A minus B. What is A here? A is theta. What is B? It is phi plus theta by 2. Now with this, you will be able to find the length of perpendicular from this line on the origin. So this is the line. Okay. And you are supposed to drop the perpendicular from origin. Denominator, what you write? A square plus B square, which will be 1 here because of identity. Okay, this will change to 1. And what about numerator? First two terms will become 0 because we are dropping perpendicular from origin, and in place of x and y I will put 0. So what will remain? Minus of cos theta minus pi by 2. So denominator becomes 0, and since there is mod, so no need of negative sign inside it. Okay, this is the final answer. This is the length of perpendicular on this line from origin. Okay, so a little bit calculation based question and use of trigonometric formula. Points given were cos theta comma sin theta and cos phi comma sin phi. So first thing that we need to do is find the length equation of line. For that I have used 2-point form. Rest is calculation simplification, in which we have used three formulae: sin c minus sin d and cos c minus cos d initially, and then at the end I've used the formula of cos a cos b plus sin a sin b, which is cos a minus b. Once I get the equation of line in simplest form, use the formula of length of perpendicular from a point on a line. That will give you the answer. Then we have two questions, 10th and 11th. Okay. So I'm solving question number 11 first. Question is, we have to find the equation of line. Here it is written lines. Okay. Equation of lines through the point 3, 2, making angle 45 degree with this line. Making angle of 45 degree with the line. So first thing that we need to do, slope of given line. Given line is x minus 2y equals 3. Okay. You change it in slope intercept form. Why we always change it in slope intercept form? Because from there we'll get the slope by comparison, and angle between the lines is given. So we'll be using the formula of tan theta equals mod of m1 minus m2 upon 1 plus m1 m2. So I'm going to rewrite this equation. This comes out to be 2y equals x minus 3. Next step, we divide both sides by 2, and we will get slope of given line, which is half. Slope of given line is 1 by 2. That is coefficient of x. Now let slope of required line is m. Slope of required line is m. Now what is given in the question? We are supposed to find equation of lines, and these lines are making angle of 45 degree with the line. That means angle between two lines is given. So slope of one line is 1 by 2, and slope of other line or the required line, let's say it is m. let us use the formula of angle between the lines. Acute angle is given. Tan theta is equal to mod of m1 minus m2 upon 1 plus m1 m2. Now simplify this equation. This is 1. Tan 45 degrees 1. Here if you will take the LCM, you will get 2m minus 1 upon 2 plus m. Then 2 will get cancelled. As a result, mod is 1. Mod x is equal to a, x is plus minus a. So that is why it will be either 1 or minus 1. So this comes out to be 2m minus 1 equals 2 plus m, or m equals 3. And here 3m equals minus 1, m comes out to be minus 1 by 3. So basically I was finding equation of one line, but I am getting, well, two slopes. A single line cannot have more than one slope. Okay, single line will have a fixed slope. So if I am getting two slopes, that means I am getting two different lines. Why? Because see, there is this line. Let us draw a rough diagram. Let us say we have this line. Okay, let us say we have this line x minus 2y equals 3, and then let us say there is a point which is 3 comma 2. Okay, then passing through these points, passing through this point 3 comma 2, I have drawn a line which makes 45 degree with this line, and I can draw one more line like this. See, so basically I am getting two lines. And also one important thing, whenever I draw these type of lines which are making 45 degree with this given line, that means angle between them will be 90, and which is evident from the values of their slopes, because if I multiply the slopes of these lines, the required lines, it will come out to be minus 1. So it is in accordance with the graph, so no problem. So now what is left? We are supposed to write the equation of lines. So that is easy because both of them are passing through 3 comma 2, and we have their slopes also. So equation of required lines, we will use point slope form. Required lines are, first line is y minus y1, point is 3 comma 2, right? 3 comma 2, then slope, then x minus x1. Next line, it is also passing through the same point, but slope is different, it is minus 1 by 3. Simplify these two equations, you will get the answer. You can match it later on. Okay, so two concepts are used here. One is angle between the lines, that formula of tan theta, and another thing is writing the equation of line in different forms. So here we have selected point slope form. Now the last question here, that is 10th. We are given three lines whose equations are y equals m1x plus c1, y equals m2x plus c2, y equals m3x plus c3. All the three lines are given slope intercept form, and they are given concurrent. On the basis of this information, we have to show that m1 into c2 minus c3 plus m2 into c3 minus c1 plus m3 into c1 minus c2 equals 0. We have to prove this result. Yes, can anyone tell me what is the meaning of concurrent lines? What is
Suppose
sorry? Please repeat. What is the meaning of concurrent lines?
Lines passing through the same single point.
Yes, correct. Lines are passing through a single point. That means two or more lines are said to be concurrent. Two or more lines are said to be concurrent if they have a common point of intersection, or if all of them pass through a same point, like the given graph. So this is sufficient to prove this question. Now, can anyone tell me how you will use this information mathematically? What you are going to do and how you are going to prove this result? Yes, anyone? How you will use this information that the lines are concurrent or they are passing through the same point? Basically, if you take any pair of two lines, okay? Suppose these are the three lines.
So of the previous sum, can you just show the last two steps?
Why you are always late? Which question? Which part?
So
Which
this
question
one
you do?
only, sir, down.
11th.
So this one. So yeah, I did already now. Thank you.
All right. Okay, so we were discussing that how we'll be using this information mathematically. So what we will do, we will solve any of the two equations mathematically because these are linear equation in two variables. Okay. So when we will solve any two equations, we will get their point of intersection. That means values of x and y in terms of the coefficients. And what we will do after that, solving those two equations, the values of x and y that we are getting, we'll put those values in the remaining equation or the third equation. Why? Because that point will also satisfy the third equation as well. This is the meaning of concurrent lines. Three of them having same point or three of them passing through a same point P, or all of them are having same point of intersection. You can say it in any way. So let us solve first two lines. Solving first two lines or first two equations. So it is very simple to solve these two equations. Why? We can simply equate values of y. We can simply equate values of y. So m1x plus c1 equals m2x plus c2. Bring terms of x on the left hand side. Take x common. This is m1 minus m2x equals c2. X comes out to be c2 minus c1 upon m1 minus m2. This is the value of x. Now you can take the first form. You can take the first equation and you put this value of x in that equation. So y equals from the first equation, okay? First equation. Y equals m1 in place of x, you are going to put this value plus c1. Let us find y also. So you simplify this, take LCM everything. M1 C2 minus M1 C1 plus M1 C1 minus M2 C1. This gets cancelled. So the y coordinate is M1 C2 minus M2 C1 upon M1 minus M2. Now you will put these values of x and y in the third equation. Now remaining equation is y equals m3x plus c3. This implies m1 c2 minus m2 c1 upon m1 minus m2 equals m3x, that is c2 minus c1 upon m1 minus m2 plus c3. Now let us take the LCM. So this is m1 c2 minus m2 c1. When you will take the LCM, m1 minus m2 will get cancelled from both sides. So m1 c2 minus m2 c1 is m3 c2 minus c1 plus c3 m1 minus m2. Now we need to just prove the required result. So we can see from the appearance of the question that m1, m2 and m3 they are coming in single terms, and c2, c3, c1 they are following some sort of cyclic order. So let us write the equation in that form. So what we can do, m1 c2 minus m2 c1 equals m3 c2 minus m3 c1 plus c3 m1 minus m2 c3. Let us see if anything gets cancelled. If nothing is getting cancelled, let us take all the terms to the left hand side. Okay, m1 c2 minus m2 c1 minus m3 c2 plus m3 c1 minus m1 c3 plus m2 c3 equals 0. So now we will rearrange the terms. We will be writing these two together. Take m1 common, it will be c2 minus c3. Then let us write the terms having m2 together. Take M2 common. This will be C3 minus C1. And finally, these two. We take M3 common and it will be C1 minus C2. And overall it is 0. And this is what we are supposed to prove. So forget about the calculation. The concept is very simple. You solve any two equations and from there you find the values of x and y and you put this in the third equation. Then this way we can solve this. I think these were your 3 doubts. We have discussed this till question number 15. The rest will be solving the next class. Okay. Now let us come to the next chapter, which is sets. See, this chapter is theoretical. Okay. Whatever I am teaching you, you just go through the chapter once again. You can read it from NCERT. Okay. It is hardly there to solve anything. If you understand the theory and definitions well, you will be able to solve the question in exam. Okay.
So what is the second last step?
Second last step is like collecting all the terms to the LHS, bringing all the terms on the LHS, and then we are rearranging the terms and taking M1, M2, and M3 common respectively.
Okay, sir. Thank you.
You can see how I have taken the terms. Okay. I have shown it with the help of arrows.
Okay, sir.
All right. Okay, so regarding this chapter sets, the first thing is obviously the definition. So set is actually a well-defined collection of objects. This term has some meaning. Okay, well-defined collection. Okay, objects. This is called set. For example, let us try to understand what is the meaning of well-defined collection and objects. So, odd natural numbers. Now see, this particular sentence gives you a well-defined meaning. Odd numbers, natural. Odd numbers are natural numbers only. Okay. So odd numbers which are natural and less than 10. So naturally, these numbers come to your mind. 1, 3, 5, 7, 9. So collection of these 5 numbers. Collection of these 5 numbers which is well defined. Okay. No one else is going to write some other number. So it is a well defined collection and objects are numbers here. So this can be treated as set. Okay. One thing. Then like the vowels in English alphabet. This time the objects are alphabets and in particular vowels A, E, I, O, U. So this is also well defined. Now, like for example, they give you this, the rivers of India. This is also well defined. We can write the names of all the rivers of India. Okay. So all these are well defined collection of objects. In the third one, objects are names of the rivers. So meaning should be clear. Okay. Like in the fourth case, if I say good cricket players of India. So this is not a set. Why? Because it is not well defined. See, this term is vague. Okay. How you will define whether a cricket player is good or not, or people may argue depending on their choices. So here the term will not be clear. But if we write, let's say, the captains of Indian cricket team so far. So now the names will come naturally. Okay. So here this term good, it is not well defined. That is why the fourth one cannot be treated as a set. Okay. So well defined and some object should be there. This thing is called set. Now this was the general definition, but we need to write them mathematically also. So next thing that comes is representation of sets. How we represent sets. First thing you always note, sets are always represented by capital alphabets. Sets are always represented by capital alphabets. And some of the capital alphabets are fixed for certain number of sets. Like for example, I'm writing some standard notations here. And I think everybody knows it is set of all natural numbers. Now we all know what are natural numbers, okay? Z is set of all integers. These are standard notations which are used in mathematics. N, Z, Q, R, W. Q stands for set of all rational numbers. R stands for set of all real numbers. W stands for set of all whole numbers. Okay. Mainly you have to deal with numbers. That is why. Then sometimes mathematicians use T or Q with a dash on it, which is used to represent set of all irrational numbers. Irrational numbers. Then sometimes they will write like this: Z plus Q plus. Now you already know that Z is set of all integers. So when they write this plus sign here, which looks like it is in the power, it is not anything like power or something, it is just a notation, then you will understand that it is set of all positive integers. Similarly, Q plus means set of all positive rational numbers, because Q stands for rational number. Q plus means set of all positive rational numbers. Similarly, now you can understand what is the meaning of Z minus Q minus everything. Can anyone tell me what are the two sets which are actually same here in this list? Yes. Can you tell me which are the two sets which are actually identical here in this particular list? So I think these two.
So N and Z plus.
And Z plus.
Yes. Z plus, not Q plus, Z plus, right. These two. N and Z plus both have same meaning. N stands for set of all natural numbers. So natural numbers are 1, 2, 3, 4, etc. Z plus all positive integers. They are also same 1, 2, 3, 4, etc. Okay. So sometimes they may write N, sometimes they may write Z plus. So it is one and the same thing. So these are the some of the standard notations for sets. Okay. Now how to represent sets, that is important. So there are two methods of representing a set. Two methods of representing a set. See all these chapters, that is straight lines, then complex numbers, sets and relation. Reading of NCERT book is highly recommended. Okay, you go through this book, just read it once. Okay, and you can highlight different points and you can mark there. Okay, that will help you. And we need not to write any theory as such, then with different color pens and all. Let us save time. Let us go through the book once. Okay, read it and highlight whatever you think is important. And I'm like teaching you the whole chapter, so that will definitely help you in understanding the book also. Okay, So there are two methods of representing a set. Basically, these are called two methods. First is roster or tabular form. What happens in this? Let me write it first. In roster form, all the elements of a set are listed. It is very easy to represent set by roster form. Easiest thing to do in mathematics. All the elements of a set are listed separated by commas and enclosed within braces. Separated by commas and enclosed within braces. Braces have these symbols. Okay, braces. These brackets are called braces. Just this, nothing else. Let me give you the example. For example, if I have to write a set of all even positive integers less than 10. First of all, why it is called a set? Because it is well defined. Positive integer, even, less than 10. We know what are those numbers. So if I have to represent it in the form of set, then first thing, let me take a capital alphabet for it. Let me name it, say it is A. Do not use capital N, T, Q, R, etc. They are standard notations. So let us take some other alphabet, basic A. Okay. So let us name this set as A and let us list all the elements of this set, which are 2, 4, 6 and 8. I have written all the elements of this set. Okay. Because these are the even positive integers which are less than 10. And what we have to do in this form, we have to write all the elements. They should be separated by commas and then they are enclosed within braces. Such a method of representation of set is called roster form or tabular form. Okay, very simple. Like if I take another example, set of all natural numbers, set of all natural numbers which divide 42, which divide 42. Now once again you can name it like capital B and all natural numbers which divide 42. Let's start with the first number, that is 1. 1 divides 42, 1 divides every natural number. That means the factors. Okay, so 2, 3, 6, 7, 14, 21, 42. You write all these factors. They are the objects here of this set. They are separated by commas and now you enclose them within braces. However, there are some points to remember. Suppose this one is important. Suppose I have to write this set of letters of the word school. Let me write it in small alphabets. Okay. Suppose I have to write this set of letters of the word school. Okay. So let me name it, let's say B only or C, whatever. I have to write the elements. I have to write the elements. So I'll be writing the elements here. What are the elements here? What are the objects? Letters of the word are the objects. Okay. So I'm gonna write it. It is S first, then C, then H, then O, then L. You might be thinking where is other O? Okay. We never write an object which is repeated. This is the first and important thing that you have to remember about roster form. If an object is repeated, it is not written again and again. It is just counted once. So that is why what you have to note, elements are not repeated in roster form. So you can take this as example. Okay. So though O is occurring 2 times, but it will be counted only once. Another thing, ordering is not important. Ordering is not important. not important means you need not to consider these two as different sets. Both of them are same. Ultimately, it is the appearance of the objects, not the order of the objects. Means in the first set.
So voice is cracking.
Is it so? What about others?
Yes, sir.
So you're not audible.
Today there is
Yes.
some network problem. What about others? Is it with everyone else? Same problem?
No, sir, you're audible.
It may be problem from your
Yes,
side.
we are audible.
Yeah. Please, you also
Yeah.
try to reconnect. You try to reconnect from your side. Yes. Okay, let's continue. All right.
Okay.
So yeah, you just connect yourself. Okay. So I was saying that ordering is not important. Okay. Ordering is not important. So whether you write 2468 or you write 8642 or you write 4682 or some other order, that is okay. It will be counted as same set only. Okay. Ordering is not important or not required, or it is not something different. And second thing, elements should not be repeated in roster form. Okay. These two things you have to understand in this particular method. Rest is very simple. You write all the objects, okay, separate them by commas and then enclose within braces. So this is the first method of representing a set. Next is the second type of, or the second method of representing a set is set builder method. Set builder method. So in this method, we do not write the elements. We write some sentence. Okay. Let us understand in a simple language. Before I actually write it here, I want to tell you one simple thing. Instead of writing these objects that you can see separated by commas, we are going to use some other method where we actually do not write the objects. We represent them by the help of a common property that they possess. I am writing it in this method. In this method, all the elements in this method, all the elements of a set possess a single common property. Single common property, which is not possessed by any element, which is not possessed by any element outside the set. Outside the set. I will show you how to write it. Now suppose, let me tell you with the help of examples how we use the set builder method. That will be easy for you. Write this set A, which is A, E, I, O, U. Now you know what is this, okay? In set builder method, set builder form. So basically, you are given the roster form of the set and you are supposed to write it in the set builder form. And what they are saying that in this method, all the elements of a set possess a single common property which is not possessed by any element outside the set. I have one question for you. Can you tell me what is that common property possessed by these elements in the given set which is not possessed by any other element? What is that common property?
They are vowels.
Vowels.
They are vowels. Yes, correct. So it is very easy. See, it is very easy to represent this whole thing in the set builder form. What we do, we will just copy this. This is set A. Okay. Then we'll start with the brace. Then we'll write a small element and then a colon. Okay. This term is read as colon. And what we are going to write after it? X is a vowel and close it. That's it. How to read this whole thing? A is a set of all x. Listen carefully. I'm reading this thing which is written mathematically, okay, which is written in set builder form. A is the set of all x such that x is a vowel. This colon, okay, this stands for such that, means such that. So it is sufficient to write this. So what we do here, we do not actually write the elements or the objects. We write their common property, which will not be possessed by any element outside this set. We already know there are 5 vowels. So when I say A is a set of all x, the vowel. So what are the x can assume A, or it can be E, or it can be I, or it can be O, or it can be U. Okay. So we write some sentence, and that sentence actually highlights the common property possessed by all the elements. Let's take another example. Write the set A equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, can anyone tell me how you will write this thing in set builder form? Yes, try it. Anyone? How to write this in set builder form? Think about that common property which will not be possessed by any other number apart from this
Positive
number.
integer.
X is, see, if I let me complete.
Egg
Wait a minute, wait a minute,
colon.
wait a minute.
Sir,
No, wait a minute. Let me explain to her first. See, when you say x is a positive integer, this will not be completely satisfying the information given in the roster form. Because see, x is a positive integer, so I can take 11 as the answer. But 11 is not present here. I can take 1000. That is not there. So it is partially complete. Okay, not the complete information. Yes, now you can tell. You were
So
saying something.
all real numbers and
Such that x is
more
less
than
than.
2 but
No,
less
no,
than
let him
1
speak. Let him
possible.
speak. Wait a minute. Yes, all the numbers. Repeat once.
X is an int.
Yes, now you can
X,
speak. X is.
x such that x is less than 10.
See, this is also incomplete. When you say x is such that x is less than 10, okay, try to understand. When you say x is such that x is less than 10, then I can take 9.7. I can take 9.7. 9.7 is also less than 10, but that is not present in the set. So be accurate. Yes, anyone else?
so
X is a set of
x belongs
positive
to n and x
integers.
is less than 10.
Yeah, you are okay. Okay, yeah, you were speaking. Yes, please.
So x belongs to n and x is less than 10.
Yes, another student. You were also saying something.
X is a set of positive integers less than 10.
Now it is okay, and other guy also. Both of you are correct. See, now we are supposed to write it in the form of a sentence. So why make it a complex statement? Write it in a simple language. X is such that x is a natural number less than 10 over x is such that x is a natural number. You can see there is no square root, no decimal, no fraction, nothing. Okay, so it is a natural number, but not all natural numbers. So what you will write, what else? X is a natural number less than 10 over. Now you will get only these 9 elements, no other element beyond this. Okay, so try to write it, keep it simple. Okay, don't make it very complex. Okay, and meaning should be clear. That is important.
Sir,
Yes,
communicate that and somebody is remaining as.
you are not audible. Please be clear.
Sir, can you make us the attendance? Someone is removing me sir, again and again.
How it is possible? Wait a minute. Just wait. All right, let's take the next question now. Okay, try to write this in set builder form. Write the set A equals 1, 4, 9, 16, 25, and this goes on in set builder form. Who can write this?
X such that X is a square of natural number.
Yes, very simple. Good. So X is such that X is square of natural number. First element is 1, which is 1 square. Second element is 4, which is 2 square. Third element is 9, which is 3 square. Then 4 square, 5 square, and so on. So if I have to give a common property, if I have to allot a common property to all of them, then we can understand very clearly that they all are squares of natural numbers. So A is a set of all x such that x is square of natural number. Now there is no limitation because the elements go on. Basically these type of sets where after comma we write something called dash or we put something like this which goes on, then these are termed as infinite sets. That means infinite elements will be there. So we will see when we will be going through the definitions. Okay, so now you have understood how to write sets in roster form or set builder form. Based on this you will be solving exercise 1.1 of NCERT. Till this NCERT 1.1 exercise is covered. Okay, the whole exercise is about writing the sets either in roster form or set builder form or changing one into another, or they can ask you questions. They will give you some sentence and they will ask you that which of the following are examples of sets. So you should remember that sets are well defined collection of objects. Okay, now next comes,
We could have written the previous question as x belongs to z also now because it's just square of the number, so it will always be positive.
yeah, that is okay. You can write x is square of some integer, but here also this thing is clear. If anyone wants to change the set from set builder to roster, then he or she will be writing 1, 4, 9, 16, 25, these terms only. Okay, so square of natural number, or you write a square of integer, that is okay, but then you will have to write a square of positive integer only. Why so? Why you cannot simply write x is square of integer? Can you tell me why you cannot write x is square of integer? Why you have to write square of positive integer? And positive integer and natural number are same. So what is the reason? Why not simply integer?
Integers include 0.
Yes, good. Because zero is absent. Okay. If like 0 was also there, then it would have been square of integer, right? But here only 1, 4, 9, these numbers are coming. That is why it is either you will be using square of natural number or you will be using square of positive integer, right? But if you simply write integer, then it will be wrong.
Understood, sir.
All right. Now we will study about some simple definitions of sets. Okay. So I will just tell you what are these. First is empty set. Name itself tells you that what is the meaning. A set which does not contain any element. A set which does not contain any element. Okay. It is also called, we have two more names for it. It is also called null set or void set. So sometimes we use the name empty set or null set or void set. All are same thing. Example, See this. Can you tell me why it is an example of empty set?
Because natural numbers don't have any decimals involved.
Yes, or you can simply say this is correct explanation, or you can simply say that there exists no natural number between 1 and 2, because if x is greater than 1 and less than 2, then yes, that is correct, that it will have a decimal part like 1.1, 1.7, and then we cannot say that it is a natural number. And after comma, what they are writing, x belongs to capital N. So this is not possible. That is why it is a case of empty set. Okay. We have some symbols also. For empty set, we have a special symbol, empty set. Instead of A, you might find this. Empty set is denoted by this symbol. This is called phi. Okay. Or sometimes they will just write these braces and nothing inside them. So if nothing is written inside braces, that means it is used to represent empty set. Okay. Or this symbol called phi. Then see, for finite and infinite sets, I'm not writing anything. Okay, go through these definitions. Name only will tell you what is the meaning. Finite set means they have finite number of elements. Infinite set means they have infinite number of elements. Like for example, if I write 1, 2, 3, 4, then this is a case of finite set. Why? Because it has only 4 elements. But if I write 1, 2, 3, 4 and I leave it like this, then it is clear that I am going to write so many numbers after this. That means it has infinite numbers, and we can see clearly that it is the set of all the natural numbers. So few elements are there or few objects are there, countable objects are there, it will be a case of finite set. And if we cannot count all the elements, then it will be called infinite sets. Okay. Then there is this term called equal sets. Another simple definition, two sets are said to be equal. Two sets are said to be equal if they have equal number of same objects. See, this is important. Two terms are important, equal, same. When you will say that two sets are equal, when the two sets have same number of elements and objects should also be same. What I want to say, suppose I have a set 1, 2, 3. I have another set ABC. Both have same number of elements. Both have same number of elements, but they are not equal sets. Both have same number of elements, but they are not equal. Why? Because elements are not same. Okay. So let us take a case of equal sets. We write 1, 2, 3, and we write, let's say 2, 1, 3. Now it is okay. Why? Because number of elements are also same, and the values or the appearance of the elements or the objects themselves, they are also same. So both of them are same. That is why we will write A is equal to B. Okay. So remember this thing. Same number of objects. Okay. Same number of objects, and the objects themselves should be same. Not just the same number of objects. That will not be a case of equal sets. Okay. We have another name for it. If the number of elements are same. If the number of elements are same. Okay. Number of elements are only same. Then the two sets are called equivalent sets. And the two sets are called equivalent sets. Another name for them. Okay. So the first example, A and B here. A and B are equivalent sets. Why? Because both of them have same number of elements. Okay, very simple definitions. Just go through them once. A and B are equivalent sets. Okay, here they are equal sets. So this part of chapter is very easy. Just very basic definitions are there, and on basis of that they have framed the exercises. So with this, you will be able to solve exercise 1.2. Each exercise will hardly take 10 minutes, not more than that. I'm telling you, but just do it. Okay. Do not think that you will solve at the time of exam only. Okay, then after this new topic will come that I'm keeping for tomorrow, not today. Okay, I don't want to rush into the chapter. So what you are supposed to do, you are supposed to complete those 9 questions if you have not done till now, and you are supposed to solve exercise 1.1 and 1.2 by tomorrow before the class. Okay, you will be asking the doubts first. All right, it will hardly take half an hour to solve both the exercises, so do it. Okay, from this topic subsets we are going to start in the next class. Okay, that's it for today. Thank you.
So, so could you show those examples which you
Yeah,
gave
sure.
for set?
Yeah, sure.
I'll just take a screenshot of that.
Yeah, sure.
Thank you, sir.
All right, bye everyone.
Thank you, sir.
Bye.
So at the start you had given it, I think.
Which one? These examples?
So after you gave the definition of set is
All
a
right, all right,
well-defined collection.
all right.
There.
These examples.
Yes, sir.
You will
One.
find all these examples in NCERT. Just go through it once. Okay, do the reading.
Okay, sir. So down. I took a screenshot. Thank you.
All right. Okay. Welcome.